So welcome to National 4 Chemistry. Today we are going to be looking at compounds and how compounds form from elements. So before we look at compounds, we need to understand the periodic table. On the periodic table, the elements are divided into two groups. They're divided into metals, which are found on the bottom left of the table, and the non-metals in the top right of the periodic table. You can see this yellow staircase, which you can see drawn in black on page 6 of your data booklet. That black line divides the elements into the metals and the non-metals. So anything to the top and right of that staircase is a non-metal. Everything to the bottom left of that staircase is a metal. So we need to be able to identify metals from non-metals. Now, compounds form when elements react with one another. So when one element reacts with another element to form something new that is made of both elements. So for example, magnesium plus oxygen, so magnesium is a metal, oxygen is a non-metal. We show them with a plus sign to show that they are reacting. And then we draw an arrow to show that a transformation is happening. And they react and transform into a compound called magnesium oxide. And notice how the oxygen, the ending of it has gone from oxygen to oxide, which shows that it has formed a compound. So we had an element, magnesium, reacting with an element, oxygen, to form a compound. When we write out a reaction like this, we call this a word equation. Everything on the left-hand side of the arrow is called a reactant, and everything on the right-hand side of the arrow is called a product. We need to always put an arrow between the reactants and the products to show that they transform. And if you notice, the compound name ends in the letters IDE. Compounds that end in the letters IDE are made of only two elements. And you can usually work out what those two elements are from the name. So magnesium oxide gets magnesium, and the ox of oxide comes from oxygen. Not every compound ends in the letters IDE. In fact, there are some that end in ITE or ATE. Now, if a compound ends in the letters ITE or ATE, that means it contains oxygen as well as the other elements you can work out from the name. So, for example, sodium sulfite. Well, the sodium part tells us it contains sodium. The sulf part means that it contains sulfur, and the ITE lets us know that it also contains oxygen. Another example, potassium nitrate. Well, the potassium tells us it contains potassium. The NITR, the nitra part, tells us it contains nitrogen, and the ATE tells us that it also contains oxygen. So you have to watch out, look for the ending. If it's just IDE, only two elements. If it's ITE or ATE, that means that it contains two elements plus oxygen. Now there are two types of compound that we're going to look at. We're going to look at compounds called covalent compounds and compounds called ionic compounds. Covalent compounds form when a non-metal element reacts with another non-metal element. And in these compounds, the electrons are shared between the two elements. And examples are things like hydrogen oxide, hydrogen and oxygen, both non-metals, or sulfur chloride. Sulfur is a non-metal, chlorine is a non-metal. So that is a covalent compound. So the other type of compound are ionic compounds. And ionic compounds form when a non-metal element reacts with a metal element. So an element from the left-hand side of the periodic table reacting with an element from the right-hand side of the periodic table. Now, unlike covalent compounds where the electrons were shared, the electrons get transferred. So they move from the metal to the non-metal. And what this means is that the metal atoms become positive ions and the non-metal atoms become negative ions. Those opposite charges attract one another. The positive ions attract the negative ions, and that is our ionic bond. And examples of ionic compounds are things like sodium chloride. Sodium is a metal, chlorine is a non-metal. Iron oxide. Iron is a metal, oxygen is a non-metal. So from the names of compounds, we can work out whether they're covalent, it'll be made from two non-metals, or ionic, made from a metal and a non-metal. But we also need other ways of determining whether a compound is covalent or ionic. So we can do this by looking at things like what they look like at room temperature, whether or not they have high or low melting points, and whether or not they conduct electricity. So we're comparing covalent compounds to ionic compounds. Well, covalent compounds at room temperature can be solids, liquids, or gases. They can be any state of matter. However, ionic compounds are always solid at room temperature. Melting point means the temperature at which that compound will go from being a solid to being a liquid. For covalent compounds, that happens at a low temperature. And for ionic compounds, they melt at high temperatures. And then finally, conducting electricity. Well, covalent compounds will never conduct electricity. Whereas ionic compounds, if you can make them a liquid, they will conduct electricity, but they will not conduct electricity as a solid. So you need to be able to compare those different properties, the melting point, the conductivity, and whether they are a solid or a liquid, a gas at room temperature. Now, to help you know whether something is a solid, a liquid, a gas, we use things called state symbols. Now, these are small letters written in brackets after a chemical that lets you know if it's a solid, liquid, or gas, or if it's dissolved in a liquid. So if you have an S written after a chemical, that means it is a solid. If you have an L written after the compound, it is a liquid. A G for gas, and then the one that's odd is AQ, which means it's dissolved in water. So you need to recognize what each of those state symbols means. So that has been compounds and the periodic table and looking at the names of compounds. Your next video will look at how we come up with chemical formula for compounds.